Hello everybody, I thought I'd do this with the document camera set up today. We're continuing on our lab about the mole concept. And the mole concept really is a central concept in chemistry. In fact, what this diagram is about is if we put moles in the middle here, then the two direct connections that you can easily make are to mass, and then also you can go to number of things. And I just put things here because it could be atoms, it could be ions, it could be molecules, it could even be something like paper clips or something, but usually we're talking in atoms, ions, or molecules. And the way you get between mass and moles is using the periodic table. So for example, a mole of carbon is 12.01 grams per mole. And that 12.01 grams per mole, that's in this red number here, and that's called the molar mass. And that will be your conversion factor that has units of grams per mole. So depending on which way you're going, obviously over here, you're in units of moles. Over here, mass, you're in units of grams. So if you're going from mass to moles, you would divide by the molar mass to cancel the grams and get the moles. But if you're going from moles to mass, you would multiply by the molar mass to cancel out the moles and get grams. Right? But I mean, you don't have to memorize that. That's just dimensional analysis that we could use. Now, to get between moles and number of things, you don't need the periodic table. You just use Avogadro's number. We use the symbol n sub a here. Avogadro's number, it's 6.022 times 10 to the 23rd. And the units on this are things per mole. Things per mole of things, you could even say. So if it's atoms, then it gives you moles of atoms. Or if it's molecules, then it gives you moles of molecules. And again, you could go either way. If you're going from things to moles, you'd be dividing by Avogadro's number to cancel out things and get moles. But vice versa, if you're going from moles to things, then you'd multiply by Avogadro's number, cancel out moles, and get things. All right, so let's try this first problem here. What is a mass of 5 atoms of sodium? So obviously I have number of things here. I have 5 atoms. Of sodium. I want to get to mass. Mass is over here. Notice I don't have an arrow that goes from number of things to mass. So I need to do a two-step conversion here where I'll first go to moles of sodium and then I can use the molar mass to get to mass of sodium. So from 5 atoms of sodium, I need to cancel out the things, so I'm going to be dividing by Avogadro's number. So it's 6.02 times 10 to the 23rd atoms per mole. And I could even put atoms sodium per mole sodium to really be specific. My atoms sodium cancel and now I have mole sodium. Okay, so I'm halfway there, right? So I'm to here. Now I need to do the second step to get to mass. So I'm not done with the problem yet. It's asking for mass. So now I would use the periodic table and I'd say, where's sodium? Sodium is here, 22.99. That's grams per mole. See, I have moles, so I'll put that downstairs to cancel that. So a mole of sodium, and then my mass was that number, 22.99. 22.99 grams of sodium. Moles sodium cancel, and that will give me my answer. So on my calculator, I'd put 5 divided by, and I would do it this way, 6.022, and then I do second EE button 23, then I don't have to use any parentheses or anything, and then times 22.99 equals, and I get a very small number, 1.091 times 10 to the minus 22. Sorry, not 1.0, 1.91 times 10 to the minus 22 grams sodium. Okay, if you don't know how to use the EE button, I encourage you to try it. But if you're more comfortable using parentheses, that's okay. You can get the right answer using parentheses. All right, so that was with atoms. Now let's look at molecules. How many molecules are there in 150 grams of water vapor? Okay, so now this time, 150 grams of water. Grams, of course, is mass. So I'm over here. I want to get to how many molecules. How many molecules, that's way over here. So I'm going to have to do a two-step process, go from grams to moles to molecules. All right, so grams to moles first. So I want to get rid of grams, H2O, and I want to get to moles, H2O. And I'm just throwing the units in there, and then I'll think about, okay, what are the actual numbers? But I can see the grams H2O canceling. All right, how many grams or how many moles? Well, the periodic table tells me how many grams per mole. H2O, hydrogen times 2, oxygen times 1. So hydrogen is 1.008 times 2 plus oxygen is 16. So I get 18.016 grams per mole. So I got to put the 18.016 downstairs because that's the grams, and then that's for 1 mole. So I could put the number 1 here, but you don't really need to. You're just multiplying by 1. All right, so that'll get me to moles, but I'm not done because the question was asking how many molecules. So that's a how many things question. So now I need to do this step, and I'm going to say, all right, I want to get rid of moles, H2O, and this will get me to molecules, H2O. And then where do I put Avogadro's number? Well, it goes with the things, right? So it goes in the numerator, 6.022 times 10 to the 23rd molecules per mole. So the moles cancel, and that should be it then. So I've got 150 divided by what I had before, so I'll just put in second answer, and then times Avogadro's number, so times 6.022 EE23, and I get 5.01 times 10 to the 24th. That's molecules H2O. Okay, notice, to check for the reasonability of my answers, this mass is really tiny. Does that make sense? It does, because my sample is 5 atoms. Atoms are tiny, so if I only have 5 of them, my mass should be tiny. This one gives me a huge number of molecules. Does that make sense? It does, because 150 grams, that's a macroscopic amount that you could hold in your hand and feel. So that should be a huge number then of molecules. All right, see if you can do these practice problems on page 164 using this same method, and if it helps you, refer back to this graphic and see where you are and where you're going and what steps you have to use to get there.